Hello and welcome to Greater Birmingham and Solihull IoT, and this the technical demonstration of the new Festo Cyber Physical Lab that we have here. Today the purpose of this video is to really introduce you to the technology that's being used in part of this brand new system that we have here, and hopefully give you a further understanding of what it is and how it's working. So to start off with, throughout this demonstration you'll see that we have these pallets that are going to move around the system. On the base of each one of these pallets is an RFID tracker. This RFID tracker allows our system to have a full and comprehensive understanding of where every single product is during the manufacturing process, and also allows us to track it so that we're able to see exactly what happens in what order. To accomplish all of this, we have a large computer system running over on this side of the room, where we're able to track every single order that takes place across the cyber-physical labs and across the cyber-physical factory. We can take a further look at this piece of equipment later. Coming back to our rig, we already have a product which is started and ready to go. So when I place this pallet onto the system, it will pick up that it is an empty pallet and therefore will be ready to start. Let's do that now. The first station is this one here. As the pallet moves around the stations, you'll notice that it moves into the center of each station where there is an RFID reader. At the point at which the pallet arrives, the RFID reader communicates back with the MES system and asks if there's a job to do. In this case, there was a job to do, so this magazine deposited a single bottom plate onto this pallet. It'll then move onto the next station, which is a quality control station. This station uses two lasers to perform a quality assurance check. You'll notice that each one of the laser points at a different part of the product and performs a height reading. The station will then determine if the part passes the quality control. In this instance, it has, so therefore the product has moved on to the next station. This station is a drilling station, and the idea behind this station is that we're showcasing technology between communicating PLCs. We have the master PLC in the bottom, a Siemens PLC, and we have a slave device running at the top as a Festo PLC. The communication between these PLCs allows the drilling process to occur. Once the drilling process has occurred, we simulate the drilling of two holes into either side of the product. Then the product moves on to the next station. This next station is really cool. It's meant to represent an Amazon warehouse or some sort of picking station. The idea being that we will receive some manual instructions on this HMI and we'll then follow them out. So now I've received an instruction on the HMI that is telling me to add a PCB and two fuses to my product. Luckily, I also have some helpful lights up here so that I can see exactly which product I should be taking. I'll take a PCB first and place it in. And now I can see that my green light has shifted to tell me to take two fuses from this top section. We'll take two fuses out and we will load them into the PCB. 1 and 2. Oops. Let's load that again. There we go. Once I've done my job, I can press confirm and the product will move on to the next station. This next station represents the back of the product. It's a magazine exactly the same as we had over on that side, but now we're looking at the top section of the product. So as the carrier moves underneath, again, the process, to remind you, is that the carrier will communicate via the RFID chip to work out which carrier it is. A message will be sent back to our computer system to see if there is a job to do. If there is, the job is performed, and the product moves on to the next stage. Because every single process is tracked, what we're able to do is to take this product and put it back through the same station. If we do that a second time, we'll see that this time no back lid is given. That's because the system knows that this activity has already been carried out and that it doesn't need to do it for a second time. So the product moves on to the next available location. This station is a fluidic muscle station. This is a really interesting technology provided by Festo, where we have these flexible muscles. As they fill with compressed air, they expand horizontally, which allows them to contract vertically, thus providing force on the item below. In this instance, we are using this force in order to clamp together the two halves of the product. So we can see that as it moves past this point of the station, the product is now clamped together. Finally, we move on to the last station in this CP Lab process. This is the output station. The idea now is that our product is fully formed and ready to be delivered to the customer. So when the product arrives in the central station here, the gripper will move into the down position, grab the product and deliver it to an output slide. Then we have a cobot which is ready to pick up this final product and package it ready for distribution to our customers. In this instance, the cobot is a Universal Robots cobot provided with a custom Festo end effector. I hope you've enjoyed this demonstration of the CP Lab and some of the exciting technologies that it offers. As we move through the rest of the system, we'll show you some of the more advanced technologies that we have to offer on the Festo Cyber Physical Factory.